Thank you very much. Thank you. Yes. Yeah, I was going to highlight the point. This is real-world application. It's actually current live real-world application. So I know we've just had 2 presentations on research standards, so everyone's kind of primed in quite a critical kind of mindset. But we can relax. This is real-world application. Not held to quite the same standard at this point yet. So my name is Hastie. I'm the principal simulation engineer at Simulate. Put that in context, I lead up a lot of the consulting work, training, and a lot of the coaching for people that are using simulation or getting into simulation. My own background's from engineering. I did a lot of work in manufacturing, production, started to focus on Lean Six Sigma, process improvement, and that kind of led me into using the software and getting started with simulation. In my time with Simulate, one of the things I really enjoy about the role is the amount of variety we have in the different processes that we get involved with, different companies. Most of my attention's been on automotive, transportation, supply chain, but I'm also doing healthcare, and in this topic we're going to look at a contact center. So today's topics, we're going to start off by looking at Erlang, and particularly Erlang C, which was developed by Erlang, the Danish mathematician. We're going to look at some of the benefits and the kind of drawbacks of using that approach for contact centers. Then we're going to look at simulation as an alternative, and we're going to try and do a walkthrough of a current live simulation that I'm using. Again, I'm emphasizing that because this is a work in progress. If anything goes wrong, that's my get out of jail card there. Okay, so just a very brief kind of introduction about contact centers and where we're at with those. Traditional kind of contact center models and traditional kind of queuing theory that Erlang worked on was very much in this sort of upper image here. It's a linear system. There's one type of call that comes in. We have one type of agent, and we kind of make our assumptions around that. What we're most typically looking at in kind of modern, larger call centers now is you have multiple different types of calls coming in. You have not just multiple agents, but you also have agent pooling and agent groups. There's a lot of dynamic routing. There's a lot of control by IVRs and ACDs. So it's a very kind of dynamic system. There's a lot of crossover between agents. There's a lot more kind of interaction during calls and in the queuing process itself. I also have to highlight social media because that makes this a current presentation. One of the big kind of areas that's very active with contact centers is if your staff are not being fully utilized for receiving inbound calls, what opportunities do you have to make outbound calls, ringbacks, back office operations such as emails, and actually increasingly now also updating things like social media. Is there a Twitter account in the company you need to sort of make updates to? Okay, so specifically just zooming straight into Erlang C, what's the good in using the Erlang C method? So using Erlang C-based formulas is the most popular approach for the softwares that deal with staff optimization, staff numbers at call centers. The good aspects of this is, well, first of all, it's the most commonly used, so it's out there. It is simple to use and it's very accessible. You can, within minutes on Google, find a number of online, downloadable, free-to-use Erlang C calculators. They tend to look very similar to this one here. You can get quite sophisticated ones that will break it down into time intervals and give you several options. It is a well-liked approach. But interestingly, there's an idea that some of the popularity of this approach is because it tends to give pessimistic bias to its forecasting. So if you use Erlang C, particularly for bigger call centers, you'll tend to perform better than you would expect. So there's some sort of idea that may be why it's maintained in popularity. So what's the bad with Erlang C? From a mainly kind of academic point of view, I think some of the major critical errors with it is, first of all, it assumes no abandonment. So the queuing calls will never hang up. which obviously in real life is very far from the truth. There's obviously only a certain time that people will stay on hold, depending on the type of service, before they will hang up and abandon the call. It assumes that calls arrive at a constant rate over the specific interval period. It doesn't look at things, for example, like clustering, or if you have more of an exponential distribution to your calls. And also, it doesn't typically assume that there's a transfer of calls from one interval to the next. So even if you have one 15-minute interval that has 100,000 calls and the next 15-minute interval has only 20 calls, none of those 100,000 will bleed into that next interval. So you can have this kind of bizarre sort of offset of calls per interval. The ugly, and I mean this from the point of view of, okay, so how does that really impact today's teams who are trying to organize their contact centers, trying to organize their staffing numbers? There's a number of ways that Erlang C in particular is not helpful for what teams are trying to do with their strategies today. So briefly, I won't go through every point on the chart here, but primarily because it assumes a single transaction type and identical agents, you're missing a lot of the strategies in contact centers, which are about how can you have teams that will share calls. So you may have one agent group who are your preferred option for this type of call, but if they are all utilized or of a certain percentage of utilization, you may want to transfer that to another group, as the other group may not be as proficient in that type of call. That may affect the handling time. So there can be interactions here between which agents you're using, how that affects handling time. There's priority issues, proficiency issues. There may even be time of day, geographic location issues. The way the agent groups are organized is an increasingly complex kind of area. And again, the formula doesn't cope well with that type of variation, really. It doesn't give you any options to examine those kind of options. As I mentioned, there's all these additional tasks now, like feedback tasks, callbacks, outbound, back office functions. They are not typically able to account for that within your Erlang C calculations. Thirdly, really, a lot of these tools work in a very black box kind of way, in that you're only putting in very basic parameters and you're getting a very basic set of results out. As soon as you want to experiment with some of your dynamic routing, as soon as you want to experiment with some of your IVR rules, you are going to be making a lot of assumptions and guesses. It doesn't really support that kind of strategizing. Okay, so is process simulation a better approach? Yes, there's quite a bit of evidence out there and papers out there sort of supporting simulation use. I think the key element to that for me is that very simply, because simulation is looking at the system progressing through time, you're able to actually track and interact with all of the events of the system. So we can break this down into our arrivals, our queues, our activities, and in particular how those resource agents are working. What I really mean by that is when we're using the Erlang C formula, we're really just crunching this through an equation. With the simulation, we can actually model every single call coming in, every agent who picks up that call, what conditions of that call apply to the handling time, and then watching that call leave. So because we can model every single step, it means that we have a huge amount of flexibility here. If we want to add in more detail, edit some of those steps, experiment with what we're doing with those, that's obviously something that we can just interact with and do. A little bit more here just on the accuracy and some previous papers. Really, really interesting stuff, but just to highlight one result from this. For example, if you're looking at weight errors, we know that the errors reduce as the size of the call centers increase and the size of the number of agents increases. But in the central chart, it's highlighting that even when you have a pool of 100 agents, you can still experience a weighting error of up to 30% in your modeling. Okay, so let's look at the current project, and I'll jump over to that. With this model, we're going to look at just a quick run through of the functionality. We have this set up here. We're going to run an import first of all. In this case, a lot of this has been shaped by the client's preferences. They have a very strong preference to be working in Excel. We can do a lot of this faster if we're using database pull-ins and things like that, but we're going to do it with the Excel here, so it will just take a few minutes to run. So I've asked it to select a particular Excel file. It's going to be pulling that in. Just to give you a sort of sense of the scale here, the import procedures now is pulling in about 80,000 cells. It's pulling an agent skills matrix, and I'll give you a view of what's going on here. So this is the actual Excel file that we have. There are just 2 sheets that we're actually importing, but they are quite large kind of sheets. We have a works data sheet. This is defining per half-an-hour interval all of the numbers of calls we expect in that interval. And in the staffing model, we have the same but matching up for actual staff numbers. So per half-an-hour interval, we're defining how many calls we expect. We're defining how many agents we will have available. And then the, I guess, kind of fun part of this is we have a crossover matrix here, where we're identifying which agent groups can correlate to which types of call. We have a scoring kind of matrix here, where we can define the proficiency for that agent group to deal with that call. So we've tried to keep this it's a very large spreadsheet, but it's a very straightforward spreadsheet. Within this, we can define a proficiency for each group here. So our import is complete. We'll just set this off to run for 1 day. And I'll skip to the fun part. So there's no calls until 8 a.m. And there we go. We have some of our calls coming in there. OK, so as the simulation runs, we're updating this dashboard, which is showing some of our critical results. The upper third here is looking at the actual call volumes. A green bar for calls that were answered successfully. A red bar that will go down the way if we have missed calls or abandoned calls. We then have a service level measure per interval, and that's fine, that's an expected error. And we have our agent occupation. So just from the dashboard, I can see that we have very highly utilized agent groups. This is almost certainly having quite a big impact on my service level, which is floating, around the 15%, 20% on average performance just now. So this is probably not a good scenario or something that we want to sort of be able to change here. To examine these results in more detail, I can now run an export process here. It's going to export out to the same file. That's a really fast process, but just to give you an indication of what we've done there, we've actually exported about 4.5 million cells. And the reason that we're exporting, again, the client team had a very strong preference for doing some Excel analysis. What this allows us to do is now actually jump into some pivot charts on the information here. Being Excel and pivot charts, we've got to hit the refresh. But then from there, we can see our service levels. We can focus in on a particular region or a particular type of call. So if I take one specific group, I can pull their detail out and see how they're working. So for that particular type of call, we do have some periods that we did actually hit our targets, but most periods we're missing. I can look at abandonment rates, accuracy, and there's a whole bunch of different sort of charts. One of the interesting things about this project is normally our projects are very specifically objective-based. In this case, it's more of trying to open up a capability for the team. So there's still some debate about exactly which results they're interested in. So they want to have the ability to slice the results. And it's an ongoing project, so this may evolve a little further. Yeah, so just to describe some of the design choices that we're using for this at the moment. The first thing was this had to work for the team that we were working with. Personally, I had an intention to pull it more of a databasey sort of direction. I know that would be faster from the software application point of view, but the clients, Excel is their currency in their office. That's what they're all very familiar with working with. They do all the forecasting on that basis, so they're very keen to keep it in that realm. They wanted to be able to share this with people on multiple sites, so we are now able to do that very successfully with the Simulate Studio platform, which is a way of being able to share your simulations online. And again, they were keen on having these pivot results because they want to be able to shape this quite quickly to suit multiple audiences. They have planners, they have staffers, they have strategy people that will be looking at this. The other aims here were that we needed a system that was flexible and that you can load new scenarios into very quickly, that you can run very quickly, even though we're working with quite a large data set. And we wanted to be able to support some of these other factors such as agent costing, looking at if you have multiple agent groups, but also the structure of the business is such that the agent groups are based across 5 different partners, and they have something like 18 different geographical sites that all have different cost rates and different factors taken into account. So they wanted something that could have that kind of range and that kind of scope. The other factor that's really important here is the scalability of the simulation. So if I jump back to the model for 1 second, the actual action part of the simulation, if you like, is in a different part of the simulation from the dashboard. In this case, we're modeling for upwards of 100 different lines of business, 100 different call types. The simulation will auto-build. So if you input data that has 10 different call types, it will automatically build out 10 rows here. If you have 50 different agent groups, it will build out a map of the 50 different agent groups. So it's a completely scalable model. So we're able to very quickly accommodate different size and different structures. So next steps in the project. Currently we're in a validation process. That's shown some really interesting outcomes, which already we're looking at making some modifications, primarily in the basis of how many trials we need to be running to do sort of better validations. So that's something that we're working on right now. We're looking at getting further into the staffing optimization, so looking at how we can bring in more detailed costing results to accommodate those different geographical locations. How we can also integrate this into more automated goal seeking. So at the moment, in terms of the optimization, it's very much a multiple scenario run, find the best solution, trial and error kind of approach. We're looking at seeing what we can do, algorithmically to try and improve on that. That's part of the basis of building up the simulation now to support larger trials. And then the next stage also is we want to start looking at applying this to other centres to see how transferable a lot of the findings that we've had here are. Okay, so I'm very interested if you have any comments, any questions. I think we're good for time, so